California's largest lake is shrinking. As the shoreline retreats, it exposes dusty lakebed and deepens an air quality problem for the communities around it. But beneath the southern edge of the Salton Sea, superheated underground brine may contain enough lithium to support more than 375 million electric vehicle batteries. The resource is real. Commercial production is not. After years of promises, legal fights, government support, and billion-dollar valuations, the region still has not produced battery-grade lithium at commercial scale. This is the race to transform one of California's most damaged landscapes into America's Lithium Valley. Without repeating the extraction history the clean energy transition was supposed to leave behind. The modern Salton Sea was created by accident. In 1905, the Colorado River broke through irrigation works and poured into a low desert basin for almost 2 years. The water formed an inland lake larger than some American cities. Over time, agricultural runoff kept it alive. By the middle of the 20th century, the sea had become a resort destination, with marinas, beaches, fishing, and crowds escaping to the desert. But it had no natural outlet. Water could leave mainly through evaporation, while salt and agricultural contaminants remained behind. Salinity increased. Fish and bird populations suffered repeated die-offs. Resorts emptied, shorelines retreated, and the postcard version of the lake disappeared. The sea did not vanish completely. It became an environmental obligation that California has struggled to manage for decades. The decline accelerated as less water reached the basin. A major 2003 agreement transferred conserved Colorado River water from Imperial Valley agriculture to urban users elsewhere in Southern California. Temporary mitigation water helped slow the damage for a period, but that supply ended in 2017. Today, inflows remain lower than evaporation. California's Salton Sea program says the lake will continue to lose elevation and become saltier. As water retreats, previously submerged lakebed, known as playa, is exposed to desert wind. That creates dust concerns in communities already facing high rates of asthma, poverty, and unemployment. State agencies are building habitat and dust suppression projects with a 10-year goal of treating 30,000 acres. Lithium development does not replace that work. A profitable mineral industry near the sea would not automatically refill the lake, restore its habitat, or stop every dust source. The lithium story begins several thousand feet below the surface. The southern Salton Sea sits above an active geothermal system. Underground water is heated by the earth, reacts with surrounding rock, and becomes an extremely hot, mineral-rich brine. Geothermal power plants already bring this fluid to the surface. They use its heat to generate electricity, then return the cooled brine underground. Lithium is one of the dissolved minerals moving through that loop. For decades, operators treated it as part of a difficult chemical mixture. Now, it may be the most valuable part. Instead of opening a giant pit or leaving brine in evaporation ponds for months, developers want to add a processing step to an existing geothermal system, generate electricity, remove lithium, and reinject the remaining fluid. That idea is called direct lithium extraction. Different companies use different combinations of filters, membranes, solvents, or materials that selectively bind to lithium. On paper, the process can use less land and less water than traditional evaporation ponds. It can also operate beside renewable geothermal power, producing electricity and a battery material from the same flow of brine. The difficulty is the brine itself. It arrives extremely hot, corrosive, and filled with minerals that can clog equipment or interfere with extraction. Capturing lithium in a laboratory is not the same as running thousands of gallons through an industrial plant every day for years. The system must recover a high percentage of the lithium, separate impurities, produce a battery-grade chemical, protect the equipment, and still re-inject the fluid safely. This entire promise depends on proving that sequence at commercial scale. The size of the resource explains why governments and automakers are willing to wait. A Department of Energy-backed assessment said the Salton Sea geothermal system contains at least several million metric tons of lithium under conservative assumptions. A broader probable resource estimate reached about 18 million metric tons. Another federal supply chain review said expected technology improvements could make more than 3.4 million metric tons available, enough to support over 375 million electric vehicle batteries. Those figures describe lithium in the underground system, not metal sitting in a warehouse. Geological resource, technically recoverable resource, and profitable production are three different things. The headline number can be enormous, while the first commercial ton remains difficult. If you are interested in the physical systems behind clean technology promises, the mines, water, factories, grids, and communities behind the finished product, subscribe to Local Gravity. That is where the real transition takes place. The most advanced project is called Hell's Kitchen, developed by Controlled Thermal Resources near Calipatria. The company plans to combine geothermal power with direct lithium extraction and has supply agreements with General Motors and Stellantis. In March 2026, it announced a plan to go public through a merger valuing the combined business at about $4.7 billion. The transaction is expected to provide roughly $300 million for development. Current plans call for about 50 megawatts of electricity in 2028 and 25,000 metric tons of lithium per year in 2029. But those dates are targets. Federal environmental review remains in progress, with the permitting dashboard listing an estimated completion date in November 2026. The project is not yet a commercial lithium producer. Hell's Kitchen is not the only attempt. Energy Source Minerals has proposed the ATLIS project beside an existing geothermal facility. Its plan would take brine from the power plant, remove lithium and impurities, return the depleted fluid for reinjection, and process the recovered material for battery use. Berkshire Hathaway Energy Renewables has also tested lithium recovery in the region. Its demonstration program showed why scale-up is difficult. A state-funded project report said the company terminated one technology provider's contract after insufficient progress and shifted toward other approaches. That is not proof that direct extraction cannot work. It is evidence that the final engineering is not automatic. Every project must solve pre-treatment, corrosion, recovery, purity, waste, and reinjection in a brine system that is unusually demanding. For Imperial County, the question is not simply whether the technology works. It is who benefits if it does. The communities around the sea are largely rural and Latino. County documents describe high poverty, high unemployment, and high rates of asthma. Local leaders see lithium as a chance to build skilled employment, technical education, tax revenue, and a wider battery manufacturing economy instead of exporting another raw material. California created a lithium extraction tax intended to return part of the value to local communities. The county is also developing a much larger Lithium Valley plan covering power plants, mineral recovery, battery manufacturing, logistics, conservation, and community opportunity areas. The ambition is not to become only the place where brine is pumped. It is to capture more of the supply chain. That promise also creates mistrust. Residents have heard large development announcements before while continuing to live with poor air, limited infrastructure, and the unresolved decline of the sea. Environmental and community groups have asked who controls the water, where industrial waste will go, how tribal and cultural resources will be protected, and whether permanent local jobs will match the projections. Earthworks challenged the Hell's Kitchen approvals over water and environmental review. A state court ruled against the group, but an appeal has continued. Imperial County argues that the project already passed a rigorous review and that additional delay threatens real economic benefits. Both positions reveal the central tension. Speed matters to a new industry, but irreversible decisions matter to the people who remain after the investors leave. The water question is especially sensitive because the word lithium is attached to a dying lake. The extraction projects do not plan to drain lithium from the lake itself. They target deep geothermal brine beneath the region. Most of that brine is intended to return underground after heat and minerals are removed. Yet the industrial system can still require fresh water for cooling, processing, construction, and workers. It can create pipelines, roads, waste streams, and new demands on local infrastructure. Claims of low water use must therefore be tested against permits and operating data, not assumed from the phrase direct extraction. The correct comparison is not zero impact versus destructive mining. It is one extraction method versus another in a region where every gallon and every dust control project already carries political weight. Lithium Valley is attractive because it appears to combine several national goals in one place. It could expand domestic supply of a critical battery material. It could produce constant geothermal electricity without depending on sun or wind. It could reuse an established energy field rather than opening a conventional hard rock mine, and it could direct investment toward a county that has not shared equally in California's wealth. But each goal depends on a different proof. Battery companies need consistent chemical purity. Investors need plants that operate profitably. Regulators need safe water, air, and waste systems. Local residents need jobs and public benefits that survive beyond construction. The sea itself needs restoration funding and physical projects that continue whether lithium prices rise or fall. The next milestones are measurable. Controlled Thermal Resources must complete its financing and federal review. Hell's Kitchen must build and operate the geothermal phase, then demonstrate battery-grade lithium production at the promised scale. Energy Source must move from environmental documents to construction and operation. Public agencies must show where lithium tax revenue goes and whether local hiring, education, and infrastructure commitments are being delivered. Water use, waste generation, reinjection performance, and seismic monitoring must become public operating data, and the Salton Sea program must continue treating exposed lakebed instead of allowing the lithium story to substitute for restoration. If you lived in Imperial Valley, what would convince you that Lithium Valley was a fair deal? Commercial production before more subsidies? Guaranteed local hiring? Public water data? A fixed share of revenue for health, housing, and restoration? Tell me where you would draw the line in the comments. The people living beside the resource will carry the consequences long after the first battery leaves the factory. The Salton Sea has been called a disaster, a failed resort, a wildlife crisis, and now a national resource. All of those descriptions can be true at once. Deep beneath its southern shore, heat and mineral-rich water may support a new American industry. Above ground, the lake is still shrinking, dust is still a concern, and communities are still waiting for the benefits promised by earlier development. The lithium is real, the technology is promising, the projects are advancing, but Lithium Valley does not exist at commercial scale yet. Its success will not be measured by the size of the geological estimate or the valuation of a company. It will be measured by whether factories produce battery-grade material reliably, whether the water and waste claims survive real operation, whether local residents receive durable benefits, and whether California keeps its separate promise to repair the sea. America may have found enough lithium for hundreds of millions of electric vehicles. Now it has to prove that it can extract that future without abandoning the place above it.